Okay, why don't we go ahead and get started? There's quite a lot to cover. Welcome. I'm Cliff Lynch. I'm the director of CNI, and you are at the last of the project briefings for the first day of week 2 of our virtual CNI Fall 2020 member meeting. This week focuses on the theme of transformational work within organizations and professions. We are recording this and we'll make the recording available after the session. Normally we have closed captioning, but on this particular section, we seem to have run into some kind of technical problem with it. We will make sure, however, that the recording gets closed captioned, and I apologize for it not being available for the live session. There is a chat box, and you're welcome to use the chat box on an ongoing basis to introduce yourself, share comments, etc. There's also a Q&A box tool at the bottom of your screen. We will do all of the Q&A at the end, and Diane Goldenberg-Hart from CNI will moderate the Q&A part of the session. I do just want to remind you that as of week 2, as well as the real-time project briefings that we're offering, there is also a group of pre-recorded videos that we're making available, and I'd invite you to avail yourself of those. Week 2 will go on until next Monday, where we'll have a summing up session at the 4 o'clock slot next Monday. Now, we have 3 speakers today, all from the University of Cincinnati. Xuemao Wang, who I think is well known to much of the CNI community as a leader and very active member of the coalition. James Lee and Kristen Burgess. James and Kristen are affiliated with the Digital Scholarship Center that has been set up. The Digital Scholarship Center, which I had the privilege of serving as part of an advisory group to, is a really interesting activity that is trying to make all kinds of links, partnerships, and serve in a catalytic role among a whole variety of activities across the University of Cincinnati community. And what you're going to hear today is mostly a report on machine learning driven activities that have been funded out of an Andrew W. Mellon Foundation grant to the Digital Scholarship Center. And that's more than enough from me. Let me turn it over to our speakers. Xuemao will lead off the presentation. And let me just thank all of you for joining us and thank our speakers for being willing to spend some time today filling us in on this interesting and important project. Over to you.
Thank you, Cliff. Thanks everyone for participating this session. What we like to do is I'm going to start to set some of the context, give you some of the background about our center and the initiatives. Then I'm going to transition to Kristen Burgess. She's operational manager of our Digital Scholarship Center, and she's going to talk about some of the organizational issues. After that, Kristen going to transition to the James, who is the center director, also the associate vice provost for the digital scholarship and the associate dean of the library. And he's going to walk you through this time very detailed. We have a total of the 39 slides prepared about our center's work. And then by the end, we hope we can leave about 10 minutes, if it's not the 15 minutes, to engage you for some of the questions. All right. So today our topic we titled to focus on the next generation of the machine learning which you will learn a lot of details from the James presentation. But what I like to start into talking about is this evolution for the library as the research partner and the project catalyst and the digital integrator, with a little bit of focus about the background about this digital integrator role on the campus. Traditionally, libraries are viewed as the service provider to the university. With our journey of the transformation, many of our organizations has made the progress through our efforts in the new initiatives such as research data management, digital scholarship endeavors. So in many organizations, libraries now has been achieved somewhat in say as the teaching, learning, and research partner. However, the libraries as the resource, as the source of innovative research design, as the catalyst for inter and transdisciplinary research, and even more rare, as campus leader for the digital integrator, use some of the cutting-edge digital initiatives such as artificial intelligence, machine learning, you'll learn from our center's work today, with human-centric approach. That kind of the role is not quite there yet. That's where we focus on in the University of Cincinnati Digital Scholarship Center. Through the support of the Andrew Mellon Foundation, we are going to today report to you mostly is our first grant from the Mellon Foundation support, and we just been renewed for the second grant. We will talk a little bit about second grant approach, but through this wonderful support from the Mellon Foundation, our DSC has served as the productive research catalyst in leading transdisciplinary research teams through the development and implementation of an accessible machine learning platform that has been successfully leveraged by multiple disciplines across the university. Our library-based, again, I emphasize, our library-based digital scholarship center has begun to change the perception of what we could be, the library emergent roles and the mission on the campus. So we're happy today to share with CNI community our journey on how we make ourselves closely aligned with where the university priorities are, how we work collectively in collaboration with faculty from multiple colleges across the university to address the research questions through joint creation of project design and use of the cutting-edge machine learning techniques. Those activities and endeavors have redefined the library's relationship with our university academic mission. For example, the library now has been charged to leading our university's enterprise-wide, we call the digital integration effort. About a year ago, I was named, in addition to the dean of and the university librarian, I was named as the vice provost for the digital scholarship, and the university senior leadership recently, about a year and a half ago, has selected our digital scholarship center as one of the 5 anchor team going to our to be built digital future innovation center, which I will touch base a little bit more when we talk about alignment. So by now you may asking, Xuemao, what do you refer to as the digital integration? What is the concept behind? I want to share with you my definition, what I'm trying to practice here at the University of Cincinnati. The concept itself, the digital integration, integrator terminology, was not invented by us. Actually, it's come from the former senior program officer of the Andrew W. Mellon Foundation, Dr. Don Waters. And in the University of Cincinnati, this is my definition, we refer to digital integration as collaborative efforts that drive to leverage the broad enterprise-wide digital capabilities, and methodologies to create vast efficiency, to enable, stimulate, and accelerate the transformation of teaching, learning, research, and community engagement. So that's how we thinking about digital integration. As I mentioned, everything starting with the alignment. So now I'm going to share with you a little bit more high-level information how we at the Library and the Digital Scholarship Center aligned with university, where university is going strategically, and how we make an alignment over there. Little bit about University of Cincinnati. We are the R1, Research One University in Ohio, the second largest university in the state of Ohio. We are public, by the way. Many of people are meeting me, ask me whether University of Cincinnati is private or public. We are the public university, second largest. And today's enrollment is a little bit over the 46,000 enrollment now. We founded one of the oldest long history public university, founded in 1918. Last year, we just celebrate our bicentennials. The libraries, I go very quickly, is one of the AR libraries. We have the 10 locations, plus all jurisdiction in the library system. I have the 13 locations to serve the entire university. And when I arrived here, I created this strategic plan and focus on our vision to become globally engaged intellectual commerce of the university. We created the 4 pillars of the pursuing, and which today you are here mostly pursuing of the digital scholarship is focused on the digital technology and the innovation part. 2017, university hired our current president, Neville Pinto, and to be our president starting in 2017. And he came in to create a new strategic initiative called Next Lives Here. This is the vision he set up for the university, leading urban public university into a new era of the innovation and impact. He keep emphasizing about urban public and innovation and impact. We pick up those concepts and we follow his need about the strategic platform and pathway. And we try to figure out where we align with those platforms from the academic excellence, from the innovation agenda, and from the urban impact. Under this Next Lives Here strategic direction, each of the senior vice president starting to create their own approach for the alignment, right? This strategic sizing plan is under the provost, and the strategic sizing plan is for entire academic house. You can see we have talking about the growth for the 10 years. We are currently about the 46,000, and 10 years later, we're aiming at 62,000 of the enrollment. We are not only just talking about enrollment growth, we're talking about growth about the education. Some of you may know University of Cincinnati invented co-op about 110 years ago. So we're talking about co-op 2.0, right? We also talking about growth in quality and access. Digital is at the center here. So we look at this university provost growth strategy very carefully to thinking about where we can align with the university. Recently, for the FY21, I would say this year, and after we settled down a little bit of the pandemic, university provost is asking, each of the dean to submit the new request about the new money could be available for the new investment, but have a very clear message to the deans. All the requests have to align with these 4 thematic areas. And we are aligned our Digital Scholarship Center squarely with the data science and somewhat with the justice in the digital world, which you will hear from James about some of the project example. Not only we are part of the academic house, we are aligned with the Provost. We are aligned with the VPR office as well. On the screen now, you see is our university 10 years growth plan for the research. The ambitions is become a top 25 public research university in the nation. So we look at this plan carefully. We identify where the area we can align. And the example I gave to you recently will be selected by the Innovation Center is one of the example. Now on the screen now is this is the strategy for the university grow the innovation. The innovation, we are created a whole new district called the Innovation District in the east of our campus. And the university recently launched a new initiative to build the new building here. It's called the Digital Futures Building. It's gonna be 180 square foot building with some of the new concept design about the very outward facing, industry facing, partnership engagement facing of the research. As I mentioned, our Digital Scholarship Center has been selected as one of the 5 anchor team going to this building, right? So in closing of my part here, the alignment is so important. Not only just get the new money and the new support, it is how you can really make the difference about the library's new role and the new mission on the campus. With that, I'm going to transition to Kristen, and she's going to take from here, talking about structure of the center. Kristen.
Thanks. So while Xuemao went over the big picture of UC and UCL and our focus on being a digital integrator, I'm going to introduce the Digital Scholarship Center more broadly with our mission, our structure, and our staffing. And then James will go into more of the technical aspects of our research and integration. So the Digital Scholarship Center is an academic center. It was created as a joint venture between the university libraries and UC's College of Arts and Sciences. Our core mission is to break silos and to cross wires between disciplines on campus and in the community. We function as a sort of digital innovator, Xuemao used this term as well, on campus, moving between cultural and disciplinary silos at the silos across the university to create new modes of research and teaching using a variety of different digital methods. So with that, we work kind of at the intersection of data science, the arts and humanities, and the libraries. So next slide, Xuemao. Thanks. So we are kind of what we do. We are UC's catalyst for digital methods to transform research and teaching. It's like the broad level description of that. So James is going to go into a lot more detail about exactly what we do. But we do this basically using machine learning and data visualization on large unstructured data sets. And a lot of that is also, a lot of our work also involves bringing teams together from various disciplines that don't always work together. Next slide. So the DSC has 3 main components. They're the gray kind of nodes or circles that you'll see in here. So research is that bottom left corner one. So that networked research is a big piece. We also have our core services, so digital tools development, faculty development, teaching workshops, things like that, creating digital skills. And then teaching is the other one. So doing introductory coursework, workshops, student research and faculty team labs, and then job placement and digital training. So in one of these 3 ways, we interact with any of these kind of different groups that you'll see on this slide and all the different units or departments that are represented there. So you'll see they represent lots of different disciplines across the campus. And our goal is to really be a distinctive global leader in transdisciplinary digital research. Next slide. So to achieve those three components, we rely on our awesome team. So we have recently expanded the core digital scholarships in our research team to include the UCL Research and Data Services. So we're now all one unit that reports to James, and his role as the Associate Vice Provost for Digital Scholarship, the Associate Dean of Libraries, and the Director of the Digital Scholarship Center. This partnership is meaningful for several reasons, especially including the unique opportunity to strengthen the library's role in the university research ecosystem that the Digital Scholarship Center team is already firmly embedded into through our Digital Futures work and other research collaborations. Next slide. So this is really the who of our team. At least it doesn't include our affiliated faculty or the project members that we partner with, but it's everybody on our team. So that top row there, you'll see everybody who is part of the Digital Scholarship Center, and that's really our core research team. They bring a wide range of expertise in areas such as data analytics, visualization, linguistics, library science, humanities research, to name a few. And they work very closely with our affiliated faculty members from across the university. They've built many of the tools and created a lot of the visualizations that James is going to discuss when he takes over. That second row is our research and data services team from UCL that recently joined the DSC. So this group comprises a lot of those core services that are part of our work, with activities such as consulting on data management plans, conducting workshops on data management, geographic information systems, NCBI tools, the Open Science Framework, and ORCID, just to name a few. And they also do our events such as things like UC's annual Data Day. Last but definitely not least are our graduate students. So we have a phenomenal group of undergraduate and graduate students from a wide range of backgrounds who assist in our research. And we consider that student training and partnership to be a really critical element of our mission. Next slide. So the DSC has two main phases so far. The first one we can really consider from 2016 until 2020, and that was focused on becoming this full center, focusing on the research life cycle that's shown on this slide and those different bullet points. And this idea was really heavily supported by our initial Mellon grant in 2017. The next slide, go ahead to the next slide, details a little bit about our second phase. That has just begun and was supported by our second Mellon grant that Xuemao mentioned. So, and we're incredibly grateful for that. Our current focus on this one is to expand and to deepen our existing research, teaching, and service relationships, and then to expand DSC's Catalyst model. So included in the second phase is the integration of RDS with the DSC to further grow that digital integration vision, and to support our scholars through the entire research lifecycle. So from ideation and research question development to the dissemination, publication, and expansion of the project to further iterations. So with that, I will pass it off to James, who can get into more of the details of the projects.
Thank you. Thanks, Kristen, and thanks, Xuemao, for setting it up. I'm going to stop my video because, as you can see, my video is a little pixelated, but I just wanted to say hello with my face briefly. So building off what Kristen was just discussing there are two major ways we've been trying to create an impact on our campus with DSC. And this is sort of the beginning to talk about the how of how we've implemented this vision. One part is technical, certainly. We are definitely using innovations in machine learning and AI to answer research questions. And what our two phases of Mellon support have really enabled us to do is to develop a machine learning platform and a set of tools that adapts machine learning approaches and applies them to any text and image data set for research projects. And any often gets questioned, and that's our goal. I mean, it's a bumpy road, but we're trying to make our machine learning logic elastic and broad enough that we can really be able to accommodate and analyze data sets from multiple disciplines. We apply these machine learning methods in a discipline-specific way, meaning that it's not computer scientists telling this subject matter experts how they should be approached or how these methods should be applied. We really work with faculty, researchers, students, and subject matter experts within a field to hear what they need in terms of knowledge and information and insight to be extracted from data sets. What are current research questions that are not able to be addressed using their conventional methods, and how we can adapt machine learning methods to directly help them, as opposed to simply applying machine learning methods for the sake of it. The second dimension is not technical, and I suppose, you know, when the title of our presentation talks about next generation machine learning, I think what gets the most surprise is the human aspect and the team science aspect of what we're doing. I think that a lot of what's next generation is finding a way to get human teams together to work together around these machine learning approaches. So we, as I state here, we assemble teams to really nurture unconventional transdisciplinary research questions and partnerships, those that are not recognized by sometimes by department tenure protocols or funding bodies or you know, university administration. But we try to take partnerships and research questions that are a little unconventional at the boundaries of disciplines and try to nurture them. Next slide, please. This, Kristen went into some detail about the sort of organizational mission of the DSC to cross wires and to break silos. At a nuts and bolts level, how do we do that? I think that with the merging of research and data services, that team, and the Digital Scholarship Center and our students, what we're aiming to do is provide a sort of full spectrum of capabilities that we can provide to our research and teaching partners across campus and the colleges. So, you know, it's always reductive to have a linear workflow like this, but I think it helps to visualize the sort of different technical steps that we use to enable to work with collaborators. On the far left side, you see data management, and this should be familiar to many of us. And this is where RDS really shines, research and data services. So I think that our research and data service librarians are very adept and very passionate about open science and open data culture, using the open science framework, ORCID, things like of that nature, and trying to expand them across the research community at our university. Data management plans and research data management, certainly, and you know, putting data from projects into our institutional repository as well as other repositories. That's a huge part of, that's a large part of the sort of infrastructure of our research projects. And one point that the RDS team members, when I showed them our presentation, that they mentioned to me, which I think was a good reminder, is that RDS often serves as a human welcome to some of the digital methods that we use. AI, machine learning, data visualization, statistics can be kind of forbidding to some faculty members. So the way they put it is they're sort of a gentle introduction to data culture and data-driven methods. So, you know, they can explain existing tools out there that faculty or students can use. And if they need to dive a little deeper, they can move on to the next step and work with us at the DSC. The middle phase is really where the DSC has carved its identity on campus, and it's using machine learning methods and data visualization methods to drive new hybrid types of data analysis. And I mentioned here digital humanities to bioinformatics. We've had a wide range, and we've worked with currently 9 colleges on our campus, from design to law to engineering to the medical college and arts and sciences. So it's really, we've tried to be broad enough, as I mentioned earlier, and elastic enough in our logic to accommodate all of these different fields. At the core of it, I really do feel that machine learning and recent developments in multimodal deep learning are really, really powerful, but they're under leveraged, and I think they're underused. I think that the advances in machine learning and AI have been largely exploited by several technical fields in computer science, data science, engineering, et cetera. And I think that if these methods could be expanded to other fields, it could be really transformational, but there needs to be a translation step. What we think is the translation step oftentimes for our researchers is data visualization. Whether it's a graphical user interface or some kind of point and click interface, or some kind of interpretive framework where users can explore and analyze data trends, which I'll show you in a little bit. So that's really what we focus on in terms of our data analysis in order to broaden our scope and broaden our network of collaborators, is a combination of machine learning and applying recent innovations from the past 10 years in machine learning to different fields and their data sets and their research questions, and displaying and engaging users from a wide range of disciplines using data visualization. I won't go so much into exploratory data analysis versus confirmatory data analysis, but that's an interesting cultural trend or conflict almost that we found, is that some fields don't really work in qualitative data or work with qualitative data types, and they don't really engage in exploratory data analysis, which is central to humanities and social sciences, and also in machine learning. So how do we bridge hypothesis-driven projects and faculty that are trained in that tradition versus exploratory data analysis? Finally, digital outcomes and products. We really try to keep our eyes on the finish line. Our faculty and students that we collaborate with all have certain things that they hope to gain and hope to accomplish with us. So whether it's publications, presentations, a website or an app, or grant proposal. So that last component is really where our subject matter experts and our collaborators, that's where they shine. That's where they're really focusing us on the output and what the finish line is. So in these three phases, I think our teams encompass the full sort of research and data lifecycle at our university. Next slide, please. As I mentioned just before, why data visualization? And our first Mellon grant really emphasized the need for data visualization development. I think there's been a lot of work in digital humanities and digital scholarship out there, but it's not very interpretable. And on the left here, I show an example of, in the command line, you can see the guts of the computer working. And while it's processing, while it's iterating through a data set, a machine learning process, you can't read this. This is not human interpretable. Humans do not think in terms of one-dimensional strings of numbers and words. So in order, especially for humanities and social science faculty members, we try to create visualizations for them to take the results of the AI methods on the left and put them into some kind of spatial or visual format where they can extract meaningful trends. So human-centered AI is a big trend right now in the computer science and data science worlds. But I think along with explainability, certainly, and replicability, visualization is a way to sort of open machine learning to new audiences and to gain their critiques and insights. Next slide, please. So as I said, the how element, the how dimension of how we accomplish our work is part of it is technical, part of it is human. And I'll address those each in turn in the remainder of my presentation. The technical side is our machine learning platform. So this is what is has been generously funded by the Andrew W. Mellon Foundation. And it's what we call the Model of Models platform. So we found that we were using various digital humanities and digital scholarship tools for our different projects. And we were sort of reinventing the wheel. In 2016, 2017, we realized that we were doing the same processes over and over. So what we hoped to do was to aggregate and consolidate all of our different methods in the machine learning realm and text mining and natural language processing into a single platform that where we could take any text data set, run it, index it, database it, and have it retrievable and searchable, and then also able to be inputted into machine learning algorithms. So this is, I'll give you an overview of our Model of Models platform. Next step, please. So Model of Models, as I said, really consolidates several existing technologies prevalent in digital humanities and digital scholarship and data science with an added twist, which I'll get to in a second. So underlying the actual machine learning logic are two major families of machine learning strategies to observe, as I mentioned here, latent patterns in large text data sets. One is topic modeling. Topic modeling is very familiar in the library world, in the digital humanities, and information retrieval worlds. And we use LDA, most popular implementation of it, created by David Bly. And more recently, the deep learning revolution has led to the popularity of tools like word embeddings. Word2Vec very famously introduced word embeddings to the NLP world, and more recently, bidirectional transformers like BERT are taking hold. So what we're trying to do, the reason why I call it Model of Models is that we don't really hang our hat on any one specific machine learning algorithm or its derivative family. But rather what we can do is we can input new modules with very classic machine learning methods like topic modeling and LDA, or more recent developments like language models and BERT, and be able to take our data sets and analyze it with new machine learning algorithms and produce new types of models as they come along. So that's why we call it a model of models, is that sort of you can sort of swap out different types of machine learning algorithms and architectures as they progress for different research questions. What I mentioned here is that we really have taken advantage of distributed computing and also cloud computing to enable us to run parallel models. So that's another reason why we call it a model of models. It aggregates multiple models in parallel to compare word usage within a corpus in those distributed models. So basically what we do is we can use Amazon Web Services or high performance computing cluster, and we're taking advantage of Hadoop and Apache Spark and distributed clustering architectures to spread a task into n number of different instances. And what we can do is we can take 6 models, for example. So the main way that we do this is we run 6 models in parallel, and then we aggregate them and compare the resulting models and the word usages from the 6 parallel independent models and combine them on top of each other. And what that allows us to do is 2 things. One, we can confirm consistent topics across all models. So it really boosts the signal. If a cluster of words or a topic or a certain trend in the language is showing up at a very high rate of probability in 6 models in a row, that sort of boosts its score and it's weighted differently. However, if they're one-off topics or one-off clusters or trends, those are sort of suppressed. They're and likewise, underrepresented topics that might not have appeared in a single model representation can be boosted as well. So it's using machine learning and distributed computing to really run many replicates at once to increase user confidence on one hand. I feel that a lot of our collaborators felt were a little wary at first of the brittleness or the variability between models. So this model of models technique has really increased user confidence in the results, but also interpretability, because it really emphasizes the highest probability, most stable topics at the top tier of model results, and sort of pushes down the trailing tail of sort of outliers. Next slide, please. One thing we've been working on a lot at the end of our first Mellon grant, and then we are really expanding in our second grant, is validation. How do you, AI, there's a lot of writing and thinking going on about the replicability crisis in AI, and how deep learning algorithms and AI algorithms are this black box that are very mysterious and so brittle, and when you put them into the real world, they don't work very well. So we've come up in our various projects and publications with various ways to build into our platform various validation methods to boost the replicability and the interpretability and the trustability of our work. One is internal, we do internal validation measures. I won't go into detail into all of these, but we use various topic coherence measures, which basically assesses the percentage of difference or variability between clusters of words and trends within each of the 6 parallel runs. And obviously between the 6 individual runs, if there's a huge gap and there's wild swings in probability, something's going on here. So that just flags that the model result might not be that coherent. External validation, and this is where I feel what's so next generation about our work. The algorithms we're using are tried and true, and they're trusted, and they've been well tested, but they have not really been integrated with human validation. And so what I feel like the external validation is, and trusting the human and finding a way for the human to enter into the black box and interrogate the black box, is really what's where we're trying to make a change here in machine learning and analytical culture. So external validation. So what we do is we take blind subject matter experts, so our collaborators. So whether it might be the faculty member we're working with and their students or class, and they tag a randomized sample of a model result. So I say a randomized 20%. That's the ratio that we normally like to use, but it needs to be a sufficient sample size, as you can imagine. So it has to be over 1,000 document model. So based on this random 20% model, tagged by subject matter experts, they look at the model results and they literally annotate and tag different clusters, saying, okay, this seems to be about literature, this seems to be about politics, etc. And then we take a blind human coder panel we have several collaborators that work with us and their labs and their graduate students that have no subject matter expertise, and then they assess and tag and annotate the same randomized model. And then we assess the percentage agreement between the subject matter expertise human tagging and the blind human coder subject tagging. There needs to be at least a 70% agreement. Otherwise, this external validation measure shows that the topics are not coherent. Regarding the replicability crisis, we're really trying to tackle this head on, so our users and our collaborators can trust our methods. So we're using the pattern recognition capabilities of machine learning and natural language processing methods as an information retrieval technique. It's not like a genie in a bottle that we rub and then we get a model result that we said, oh, surely it must be true. So we're not interested in classification. As an information retrieval technique, the clusters of words and the documents that we retrieve really are for the human user to assess the validity and the robustness of the model results. And as I say there, the goal is to provide models capable of evaluation of our panel of multiple independent coders. As I say here, part of the reproducibility and replicability stakes that we've set for ourselves is that we've run parallel replicates in every model. So it's not just a one-off n=1 model that we can perform our research on. Depending on the research question and the discipline that we're working in, we run between 6 and 20 runs in parallel. So for some disciplines, like some of the biomedical projects we're working on, the burden of proof is very high. So every time, we need to run about 20 models in parallel to really trust our approach. So that's really our hybrid, the team-based approach to the technical side of what we do. It's a hybrid machine approach where the human judgment of subject matter experts verify and tag the model results. And there's now a burgeoning literature in the past 3 or 4 years showing how this blend of human judgment and machine learning model outputs outperform, no matter how optimal or how well honed, that outperforms a purely machine-based analysis. I'm not going to get into classification here too much today, but suffice it to say that when we do classification tasks, this hybrid ML approach manifests itself as a semi-supervised learning approach. It's not purely unsupervised, as some deep learning approaches do. Next slide, please. So in building the model of models platform, I described the underlying logic, distributed computing, and running several jobs and models in parallel, and with the goal of giving our human coders and human subject matter experts something to assess, something that they can assess the viability of for their research question. So in order to do that, the input are different data sets. So we have certain data sets that our researchers come to us with. They have a data set, a small local archive, a small local data set, something that they've digitized. But more often than not, they're interested in analyzing some of the very large digital archives out there that have recently been open source and digitized in the past decade or two. So here's just the first screen of our model of models page, where the user can select the database that they're querying and they're analyzing. And it's very important for us to make our platform interoperable with the large data sets out there. So I just give some examples here that our platform is compatible with the HathiTrust Research Center extracted features dataset, JSTOR data for research datasets, based on requests that you can put into DFR, Chronicling America, the Text Creation Partnership, and the Harvard Open Case Law Project that is trying to open source US case law against LexisNexis and Westlaw, basically. On the far other end of the spectrum, on the medical side, there's a lot of text out there. So there's the over 30 million abstracts in PubMed and the over 2 million full text open articles in PubMed Central that we are compatible with. US patent claims back to 2004, and electronic health records in the FHIR data structure. And that gets a little tricky because those need to be IRB approved and they need to be HIPAA compliant, but some of our medical and clinical projects are interested in analyzing electronic health records. Also, large batches of social media data, Twitter, Instagram images and captions, and Reddit threads. So it's a wide range of data sets of different scales. The largest probably being the PubMed data set with over 30 million articles. But what we want to do is the underlying data structure metadata needs to be interoperable with our platform, so users can pick and choose what data set they want to use for their underlying analysis. Small corpora, I get a question about that sometimes. We'll help you read them. If someone came to me about a year ago saying that they had 100 documents that they wanted to use machine learning on, and I said that 100 documents sounds like a human reading problem. Like, so we can sit down and read it with you, but it's not really something suitable for our methods. Next slide, please. So this is the output. I'll show you some different outputs that we construct using the model of models method. But you select a data set based on your discipline and based on your research questions, where you can begin to ask questions and begin to ask your research questions. The ultimate model is this, and this is really the interface that users, the information retrieval and assessment page. So on the right-hand side here, you see the clusters, and the clusters are the aggregated topics and the aggregated clusters of words that have the highest probability of occurring together within a corpus. So if you look at cluster number 12, for example, the words children, patients, asthma, RSV, and age. These are words that have a disproportionately high probability of co-occurring within the corpus. And subsequently, each cluster shows words that co-occur and within the same word range, within the same sentences and paragraphs a lot. And in the center here, so that's a tabular representation of word clusters. In the center here, this is one of our innovations, something that we've created for data visualization, is a vector space model representing these topics in a two-dimensional space. So basically you can assess where the hotspots and where the clusters of words and language are, and then what the distance or the similarity between the clusters may be. So the position in the vector space is dictated by word similarity. So the assumption being nodes that are very close together have more similar words in their topics and clusters. And those that are more distant have less similar words. And the edges between the clusters here is determined by document similarity. So it's the amount of documents shared between clusters. So you can assess word and document level relationships in this visualization. On the left, for the documents, that's really the information retrieval pane. So it shows all the documents that contribute to each cluster. And then it allows users to establish ground truth by reading the articles contributing to each cluster. Next slide, please. So we have multiple visualization outputs based on a single underlying method. I won't go into each one of these in detail, but you can see that on the left here, for a certain data set, users can search, filter, and explore the underlying texts that they want to input into the model by time range and by word frequency and word use. One of the visualizations that we use on the right-hand side here are word trees. This is a specific request of some of our users. Some of our collaborators have wanted to look at this sort of hierarchical structure rather than a network structure. So based on the same underlying model, we can produce different visualization outputs based on the sort of cognitive and the analytical needs of our collaborator. Next slide, please. Two more examples of it's based on the same model, different outputs. So a Sankey diagram, the cluster table and the document retrieval pane for information retrieval are the same on the left, but the Sankey diagram allows you to see sort of ubiquity or rareness of word use across the different clusters. And on the right is a classifier using a BERT language, more a deep learning language model method. So that's a different kind of output altogether that we can use based on the same method. Next slide, please. So I just, to wrap up here, I just want to show some of the range of what we're doing. So many of our projects are in the digital humanities, and that's one of our real strengths. So example here is using the model of models for publication, recently showcased in PMLA, that I co-authored on sort of unlocking the Anthropocene archives, using text mining to identify sort of a history of a human's impact on the earth using the model of models method. Next slide, please.
James?
Yes. Could I get the next slide?
Oh, I think it's up.
Oh, okay, here it is. In the digital humanities realm, this is just one example of a recent research project that is forthcoming in Post 45, where we're analyzing audio archives and digitized audio archives and identifying language use in different archives to show hotspots here. So this is just an example of a different visualization output for audio archives. Next slide, please. In the social sciences, we have projects in sociology and journalism and communications. This is one example of analyzing Twitter. So using our platform to analyze linguistic and semantic trends within political discourse on the right wing and the left wing in the 2016 election that was recently highlighted in New Media and Society. So different visualization output, certainly different data set based on the needs of our social science collaborators. Next slide, please. And one area that we're really growing into in the digital humanities realm for our second grant is minimal computing and using mobile devices and creating apps, applying some of our machine learning data visualization technologies on apps, which I won't go into a lot, but it's assuming that you do not have the resources of high performance computing, how can a phone or an iPad use some of our methods? Next slide, please. And in closing, I just want to highlight some of the DSC's very unconventional and surprising projects with our Academic Health Center and College of Medicine. What I would say is that these projects really are a two-way experiment in disciplinary contact. So we have taken on the role of teaching clinicians and STEM faculty and practitioners about how to work with qualitative data and how to work in sort of in a humanistic or social science mode. Next slide, please. So here's one example that with our Children's Hospital Medicine division, we're looking at clinical uncertainty and looking at language within electronic health records where doctors and nurses waffle or hedge or demonstrate uncertainty so they can flag and identify, are there signs, are there linguistic tremors demonstrating this kind of uncertainty within the electronic health records? Next slide, please. Similar project, for the sake of time, I'll pass over this, but, and if you go to the next slide. And this is an example of using our model of models method with the foster care center at our Children's Hospital to identify some of the social determinants of health and wellness in foster children that they that pass through their center, and identifying how these children and the clinicians and the social workers are identifying the plight of these patients, and how the current data structures and the current clinical methods do not adequately reflect how they're expressing their condition. Next slide, please. And I'll skip over this one for the sake of time. Second phase, we're really expanding into multimodal machine learning methods, text and image. So identifying in art historical data sets like the Dunhuang caves on the left, and on Instagram, using our machine learning logic to sort of cluster text and image within data sets for our research questions. There's been a lot of demand for this among our art historians, artists, and design faculty. Next slide. And what we're also doing is expanding our Jupyter Notebook pipeline. So we're taking each phase of our machine learning platform, and rather than taking it as one package, extracting different sections for our researchers to use in a sort of DIY method for certain slices of our methodology. And the last slide, please. So in wrapping it up, here's the location of our current Model of Models platform. It's modelofmodels.io, as well as the Digital Scholarship Center website. In sum, the second grant objectives, we are going to expand to 15 subgrants. And we're looking for more partners. So if your institution is interested in using the Model of Models and our Jupyter libraries for these kinds of digital scholarship projects and expanding it on your campus, we'd love to work with you. And of course, as we mentioned, we're very grateful to the Andrew W. Mellon Foundation Public Knowledge Program for their support of all of these activities. Thank you very much.
Wow, thank you. That was an amazing presentation, and the breadth of work that you all are involved in and the possibilities are quite astonishing. Thank you so much for your presentation. I will jump right into the questions because we already have several queued up. The first one comes from Nicholas Taylor, who asks, how does the DSC evaluate and populate the pipeline of candidate projects to collaborate on or facilitate? How do you benchmark capacity?
James, you want to take that one on?
Sure. What I say is that's partially the goal of digital integration, is to separate out tasks and projects and queries that are more service related, that can be addressed by our research and data services team, and those that need more in-depth research collaboration with the DSC. That said, I think the Model of Models platform and the tools we've created are a means to create more capacity. So initially we were manually creating these tools over and over again. So we wanted to consolidate that effort, and the platform really allows us to get a head start and have a sort of pipeline of analytical capability that we use for each project.
Fabulous. Okay, thank you for the question, Nicholas, and thanks for fielding that, James. Next, we have an anonymous attendee asks, do you support long-term dissemination of the visualizations? Do you have any sunsetting policies?
Good question. That's an issue that we've really been working on with our research and data services team in terms of the long-term, how do we store, and what's the sort of preservation and repository strategy for a lot of our resulting data sets. I think right now, the best answer we have is we are preserving and putting into repositories the underlying matrices or the underlying data tables for the visualizations, so people can sort of quote unquote rehydrate them down the line. So we're not necessarily preserving for long-term the visualizations themselves, but the underlying data that someone with enough, someone could easily pop them into Excel. It won't look exactly the same, but they can see the same trends, basically. I think that's the simplest way to do it so far. If you have suggestions, I would love to hear more, because that is a problem.
If we've got any suggestions, please chat those through. Our next question and comment comes from Dawn Waters. Dawn says, hello to everyone. Terrific presentation. Good to see you all. Can you comment more specifically on demand for your services? Do you have to beat the bushes for projects like the ones you've mentioned, or are faculty queuing up to work with you? If they're queuing up, how do you sort out which projects to support?
That's a great question, and that relates to the capacity question earlier. We don't have to drum up projects. I think word of mouth has helped a lot. I think we have several early adopters in different departments and colleges on campus, and they've talked to their colleagues, and then their colleagues have come to us with research requests. What I would say is that we try to phase our project. So let me, some of our projects are ready to go. Some of our collaborators come, they have a data set ready. They have students that want to work. They have a sabbatical and they're ready to roll this year. Others are more aspirational. They have an idea or a hunch. They have no idea how to address it, and they've never worked with digital tools at all. So those aspirational projects, we coach them for 2 to 3 years down the line. They might be ready to have a full-blown research project. Whereas those that are ready to go, we can start next semester. So we do an initial triage phase to see the sort of the maturity and the readiness of the research question and the faculty member, and we sort of stagger them semester by semester.
I also want to thank Don for asking that question. To add one more comment, the visibility on the campus for the Digital Scholarship Center is also helped for faculty line up the engagement with Digital Scholarship Center. In addition to the example I gave, we were selected as one of the 5 anchor team for the Digital Future Building. We were actually invited by the Board of Trustees, James and I, to give the presentation to the Board of Trustees. And so all of this are helped. Provost promote, VPR promote, so that will make the visibility pretty high on the campus.
That's terrific. Thank you so much. Thanks, Don, for the question. Next, Emily Gore asks, can you talk about the computing power setup you have to process this data? You mentioned HPC. Is this work being supported by your campus data center? Could you share information about this?
A very good question. That's a big component of the work we do. What I would say is that some of our computing we use on the cloud, whether it's Microsoft Azure or Amazon Web Services. I would say a lot of our prototyping goes on there. A lot of our jobs that are small enough scale, we can just do in our lab. Desktop computers are high powered enough. If you have an 8-core machine, you could run our pipeline locally. What I would say for long-term use and where our platform is actually housed and served, it is the campus high-performance computing cluster. And interesting story, sort of related to the previous question about, do people come to us or do we have to find them out? Our aerospace engineers and our high-performance computing team at IT came to me last year, and they said that they were trying to get a NSF MRI, Major Research and Instrumentation grant, to really boost their high-performance computing capabilities. The NSF reviewers had said, you're not diverse enough. You're not really university-wide. All you're doing is like 5 people in aerospace that are using this. So you need more use cases. So they came to me to say, can you be help us craft a case for university-wide application and use cases for high-performance computing. So after I helped them break the logjam with the NSF, ironically. So it's a weird instance where I think that digital humanities and digital scholarship can actually assist other fields in surprising ways. They might have limitations, and they might be siloed in ways, and they don't know that they could actually appeal to a broader audience. And I think that we've really tried to do that.
That's really interesting. Great. Thank you, Emily. And now we have a question. Have you worked with Cadre, which is the Collaborative Archive and Data Research Environment Science Gateway?
I don't believe, I'm not familiar with that, but I'm sure one of my team members is. I'll ask them about it. Sounds fascinating.
Okay. All right. Well, we have lots of folks thanking you, and and John Dunn has just chatted in the Cadre URL. Let me just chat that out to everyone.
Great, thank you.
There we go. And I see we have another question now from Terry Wheeler. You discussed EPIC FHIR data. Clicking into your site, I do not see this data set, but it quite likely is private. If this is HIPAA protected data, do you have a data enclave for this, or do you just store the model?
Very, very good question. This has been a tricky area and a really area of learning for us, because these are absolutely the opposite of open data sets. So they are really tightly regulated. So what we do is we have an honest broker on our academic health center campus in the College of Medicine. It's the biomedical informatics department. And they have secure private servers that they use for HIPAA protected patient data. And they also de-identify all the data. So anything that could be used to sort of extract or infer the identities of the patients, they de-identify. They have protocols for this. We have to go through IRB approval for every project. So it's quite arduous, but it's worthwhile. So yeah, we do not, yeah, it's not public at all. These results are not public, and we do not house them on our Amazon Web Services or high performance computing cluster. They're on the biomedical informatics secure server. And sometimes for very, very secure projects, we have to go on site. They don't want to get the data out of the building. So like we have one of our developers actually going to one of their offices to work on it. So it's been eye-opening for me, but it's all very worthwhile. So yeah, other end of the spectrum from open data.
That is really interesting. Thanks for the question, Terry. And thank you again to all of our presenters for this fascinating talk. It's really interesting. We're really looking forward to hearing what's going to develop out of this project, and to our attendees for making time out of your day. I see we're well past time, so but we do still have some attendees. I'm going to go ahead and close down the public portion, shut off the recording, and if there are any attendees who would like to continue to hang out with us and maybe have a chat with our presenters, ask some more questions, or share your own experiences, please feel free to do so. I'd be happy to unmute you. And with that, I will wish everyone a good rest of your day, and we hope to see you back at CNI tomorrow. Take care, everyone.